I'm going to explain a simple stoichiometry problem. So here's the problem. How many grams of water are produced from the combustion of 34 kilograms of propane, the average amount of propane, in a tank for a grill? So first thing you need to ask yourself is, what is the problem asking for? So in here, it's asking for grams of water. Second thing you have to ask yourself is, what are you starting with? You are starting with 34 kilograms of propane. So, map out where we're going to go. We're going to start with kilograms of propane, C3H8. We're going to go to grams of propane. We're then going to go to moles of propane. Next, we're going to go to moles of water. Then we're going to go to grams of water. What we need to do now is write out a reaction for the combustion of propane. So, propane is C3H8. We're going to add oxygen to it, because you always add oxygen to a combustion reaction. And that's going to react to produce carbon dioxide, CO2, and H2O. Balancing the reaction, you need 3 carbons on the product side to balance out with the 3 on the reactant side. You need a coefficient of 4 in front of the H2O. 4 times 2 is 8 to balance out with the 8 oxygens on the reactant side. On the product side, you now have 10 oxygens, so you need a 5 in front of the O2, and now you are balanced. So again, we're starting off with 34 kilograms of butane. So on my T table right here, I'm going to start in the upper left-hand corner with 34 kilograms of C3H8. I now have to do the conversion factor from kilograms to grams. So I'm going to put 1 kilogram of butane on the bottom, C3H8. And there are 1,000 grams in a kilogram of butane. Notice I put the kilograms on the bottom to cancel out with the units I started with. My next step is to use the molar mass of propane to go from grams of propane to moles of propane. So, to get the molar mass, I am just going to add up 3 carbons and 8 hydrogens. So 3 times 12.01, the molar mass of carbon, plus 8 times 1.01, the molar mass of hydrogen, equals 44.10, and the units are grams per mole. So I'm going to put my grams down the bottom, 44.10 grams of C3H8 for every 1 mole of C3H8. Next step is to go from moles of propane to moles of water. I'm going to do that using my mole ratio. So if I look up at my balanced reaction, I have 1 mole of butane. Sorry, I keep on saying butane, I mean propane. And I have 4 moles of water. So it's a 1-to-4 ratio. I'm going to put my 1 mole of propane down the bottom and my 4 moles of water on top. My last step is to find the molar mass of water, to use that to go from moles to grams. So I have 2 hydrogen molecules, so 2 times 1.01, the molar mass of hydrogen, plus 1 times 16, the molar mass of oxygen. Altogether, that equals 18.02 grams per mole. So, notice my 1 mole of water needs to go on the bottom, so it cancels out. and my 18.02 grams of water go on top. Now the calculation part. So I'm going to multiply by everything that's on top and divide by everything that's on bottom. So I'm going to start with my 34 kilograms, multiply it by 1,000, multiply it by 4. Notice I'm skipping the ones because you multiply by 1, it's just going to give you the same thing. And I'm going to multiply by my 18.02. That is everything that's on top. I'm going to divide, and again I'm going to skip the 1, so if I divide by 1 I'll just get the same thing. So I'm going to divide by my 44.10, divide by 1 again, and I can type that in my calculator. Now, if I take into account that I started with 2 sig figs, I'm going to have 2 sig figs in my answer. I'm going to calculate that out. I end up getting 56,000 grams of water for my final answer.